Carl Sterling here with the topic of finding all solutions of a trigonometric function. That's topic 19 here in the Pearson e-text on page 665. And yes, I do have laryngitis, frog in the throat. First example up is 3 sine of x minus 2 equals 5 sine of x minus 1. Basic algebra facts here. If you have the same base here, we have sine of x, here we have sine of x, then we can add or subtract, multiply or divide using the coefficients here. So since it's 5 sine of x, we're just going to do a negative 5 sine of x or subtract it. Whatever we do on one side of the equal sign, we must do on the other. So they've also subtracted it here. 3 minus 5 is negative 2, and it keeps the tag sine of x. Instead of minus 2, we're going to add 2 to both sides. That kapoosh gets rid of this one. And on the other side, negative 1 plus 2 is positive 1. We do have the negative 2 coefficient, so we divide both sides of the equal sign by negative 2. We're left with sine of x equals negative 1/2. If you don't have one of these reference charts, just do a quick Google search for angles, degrees, trigonometry, formula sheet, or something like that, and take a quick screenshot of it. These are great to have. We had 1/2, which is 30 degrees. I'm sure you could even get another one that converts to radians, but I think it's pretty easy. 30 degrees, well, if it's pi for 180 and 6 times 30 equals 180, we simply divide pi by 6. So 30 degrees in radians is pi over 6. Other thing to be aware of, this is negative, so we're going down into the third and fourth quadrants since it's a negative y value. So 30 is the reference angle, but we do have to do the far line of pi minus pi over 6. Or pardon me, plus pi over 6 here. We also have to take the opposite side of the 360 degree line, or 2 pi, and we're going to subtract pi over 6. In this case, we're going clockwise, which is going to subtract. In this case, we're going counterclockwise, which is the appropriate way. So we're adding it on here. So 6 pi over 6 plus pi over 6, we get 7 pi over 6. We convert 2 pi to 12 pi over 6 minus pi over 6 to get 11 pi over 6. These both have a reference angle of 30 degrees. These are both in the negative sign quadrants, so quadrant 3 and quadrant 4. And they match up with the SOHCAHTOA opposite over hypotenuse values of negative 1 for the opposite and 2 for the hypotenuse. Since we want all values here, all solutions, I know that sounds like it's going to be a lot of work, but it's actually pretty easy. We take those two values and we simply add 2 pi times infinity of whatever number you want to plug in there. These are algebra expressions here. The letter n is just expressing as many times as you want to go around the quadrants. Alright, let's try an example ourselves. They don't have one here in the regular text, so we're going to jump back to the questions area. Page 674, that was the right one. One of the beginning sections here. Let's see. Finding all solutions of each equation. So let's give a couple of these here a go. Okay, first one up, we have cosine of negative 1/2. This one there's no actual algebra workings to do. It's already given to us, just a single cosine x. So we're going to pull up our chart here. Cosine 1/2, cosine 1/2, 60 degrees. 30 degrees was pi over 6, so 60 degrees is just going to be pi over 3. We are now referring to the negatives for cosine, cosine being the x, so we're talking about the upper left and the lower left for negative x values. So that's going to be the second and third quadrants. Since we're going to go backwards from the line upwards to get into the second quadrant, we're going to have to subtract, so it's going to be pi minus pi over 3. So 3 pi over 3 minus pi over 3 is 2 pi over 3. I just come over here, I add my 2 pi over 3, and it's so easy, I just put in my plus 2 and pi. I love it. We're also going to have a second one for that third quadrant, so we just add a comma in there. Going down, we're going to add pi over 3 to pi, or 3 over 3 pi. We're going to get 4 pi over 3. So we just put that in here, 4 pi over 3. Add that to 2n pi, and cross our fingers here. Oh yeah. Alright, here we have some of the reasoning on that one. Cosine of x equals -1/2. Using SOHCAHTOA, we have ka, or adjacent, and hypotenuse. And since it is negative for cosine, we're in the second and third quadrants. The adjacent side is -1 going back. The hypotenuse is a +2. So this is what those two angles look like. You can tell they're steeper, so those are 60s. And we use our knowledge of 60-degree angles, or you just use your total knowledge of radians. Certainly it's pi over 3. You're going to subtract that from pi to get your 2 pi over 3 here. You're going to add that to pi to get your 4 pi over 3 here. And then we simply add the 2n pi to those values. Well, just for fun, we'll try one more here. We're going to subtract the 4 from both sides. That's 4 sine theta. 6 minus 4 is 2, so we get 2 sine theta. The -1 over here, we're going to add 1 here and add 1 to the other side. We're going to end up with 2 sine equals 1, or sine of theta equals 1/2. Well, sine and 1/2, this just keeps coming up today. 30 degrees, pi over 6 just keeps on coming up today. So we do have pi over 6. Let's get that in here while it's fresh in our mind. And of course that's plus 2n pi. Since this is positive and we're talking about sine or y, we're also going to be positive in the second quadrant. To get that one, we actually have to take pi and subtract pi over 6. That's 6 pi over 6 minus pi over 6, which is 5 pi over 6. And once again, it's just plus 2n pi. Nice. Here we have the math drawn out on that one for you. That was 6 sine theta minus 1 equals 4 sine theta. We subtracted the 4 sine theta from both sides of the equal sign to keep everything nice and balanced. We get 2 sine theta minus 1 equals 0. We went ahead and added 1 to both sides. We do get 2 sine theta equals +1. We divided both sides by 2 to get sine of theta equals 1/2. Good old 1/2, that's positive sine, that's positive y, quadrants 1 and 2. With using our chart, we did see that sine of 1/2 is 30. And of course 30 is pi over 6 in quadrant 1. We subtract it from pi, or 6 pi over 6 in quadrant 2 to get 6 pi over 6. And of course we take them both and add the 2 pi n and separate them with a comma. Here we are with the final example. I just wanted to throw one in with tangent here. We have tan of x equals radical 3, or radical 3 over 1. We just pull out the old angles in degrees. Tan to angle here, we have tangent radical 3 is 60 degrees, which is pi over 3. Another very common one to have come up here. So we have pi over 3 for tangent. Let me go ahead and pull my work over here. Tangent is just from 0 to pi, from negative pi over 2 to pi over 2. It is not a 2 pi cycle. So we have to be careful with that, just from 0 to pi. So in that case, since even though it is positive in the third quadrant, we do not include that one. That is not included. But we do leave on the plus n pi nature to it to repeat itself. It's not a continuous, it's just going to start over and repeat itself. So we'll try to plug that in here, pi over 3 plus n pi. Could also put pi over 3 plus pi n. The order does not matter there. Go ahead and test me on that one. Pi over 3 plus n pi. And there we have it. There was no comma space and then adding in that third quadrant because, again, tangent is only from 0 to pi.